All right, everybody, in this video, we're going to be writing recursive formulas based on the sequence given to us. Most of you will probably find this easier than writing the explicit formulas, which we just did. So, without further ado, let's get going. First and foremost, I know that I start off at 55. So, when I write my recursive definitions, I always have to include what is my first term. So that is a piece that you have to have included. And then what are we doing to each term to get the next? So to go from 55 to 50, what am I doing? And then 50 to 45, what am I doing? 45 to 40, what am I doing? Well, it looks like they're just decreasing by 5. So I'll start off at 55, and then I take each previous term, subtract 5, and then we're good to go. Remember this a sub n minus 1 term. That just means whatever term came before it. So you don't have to plug anything in here. It'll always feature an a sub n minus 1. Something to keep in mind there. All right, next one. We have 4, 8, 16, 32, 64. Well, I need to have what is my starting term. So I start off at 4. And then what am I doing to go from 4 to 8? And then 8 to 16. And then 16 to 32. Well, it looks like I'm just doubling. So my pattern here is take your previous term and double it. 2 times a sub n minus 1. That's as simplified as you can get it. Remember, a sub n minus 1 will always be featured in a recursive, and that just means the previous term. Number 3, 1, 5, 9, 13. Well, we're starting off with 1, so my first term is 1. And it looks like, let's see, 1 to 5, 5 to 9. It looks like I'm increasing by 4. So I'm just adding 4 each time. So take your previous term, add 4 to get the next term. That's our formula. Ooh, this one might be a little tricky. It's got fractions. Dun, dun, dun. Well, let's see. Hey, there we go. I know my first term is 1/2. And then what am I doing each term, each term, each term? Let's see. Well, the top isn't really changing, right? So I could just argue that I'm multiplying by 1. And then the bottom, 2 to 4 to 8 to 16, the bottom is doubling each time. So I'm multiplying by 2. All right, so I multiply by 1 in the top, 2 in the bottom. So I'm just multiplying by 1/2 each time. All right, that's not too terrible. So 1/2 times the previous term, or what you could also say is take your previous term and divide it by 2. These two pieces are saying the exact same thing, just different notation. So please keep that in mind. All right. Let's see, 4, 14, 44, 134. Whew, what are we doing to this one? What are we doing? How do I go from a 4 to a 14? And then a 14 to a 44. Looks like I'm adding 10, then I add 30, then I add 90. Oof. Interesting, 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 interesting. So we have to figure out what are we doing to each term. It's not a consistent pattern, right? So remember what I said before? If it's not a consistent pattern, maybe look at exponents or radicals. Maybe we're squaring them or raising them to the third power. What's happening here? Well, for this one, neither of those. All right, looks like we're tripling. So we're taking 3 times our previous term, then adding 2. So 3 times 4 is 12, add 2 is 14, checks out, okay. 3 times 14 is 42, plus 2, checks out, okay. So that would be our pattern. Remember, a sub n minus 1 refers to our previous term. So what are you doing to your previous term to get to the next one? All right, now let's take a look at a word problem. Here it says we walk 1 mile the first day of training, 1.2 miles on the second day, 1.6 on the third day, 2.4 on the fourth. If we continue this pattern, how many miles are we walking on the 7th day? So for this one, I wasn't sure if it was going to be more advantageous to me for me to do an explicit pattern or a recursive. So just to play it safe, I indexed all of my terms, 1, 2, 3, 4, 5, 6. So first term, second term, third term, fourth term. And I tried figuring out what am I doing to each term to get to the next one. And then I also looked at, okay, if I were to think of this kind of as a recursive idea, how do I go from one to the next, right? So I add 0.2, then I add 0.4, then I add 0.8. So what am I doing from one term to get to the next? Well, since I'm actually only going to 7 and it's not asking for a formula, I don't think I'm going to go through and do it, right? I'm not going to make a formula. Instead, I'll just kind of count this out. So to get to the next term, I'd add, let's see, double that, 1.6, then add 3.2, then add 6.4. All right, so we'd get 13.6 miles. Next one. Same thing here. I indexed them in case it was kind of more advantageous for me to come up with an explicit. Then I also figured out what am I doing to each term if I wanted to think of this with a more recursive pattern. This one, it's asking for the 10th month. So it's going to be a little bit extra work to figure out, okay, how do I get all the way to the 10th month? But at the same time, it's not going to be terrible, right? Because it's not like I'm figuring out the 80th month. So it looks like I add 2, then add 4, then add 6. Next would be add 8. So I'm at 70. And then I'd add 10, 80. And then I'd add 12, 92. And we could just continue that as we go through. And if you have a calculator, this will take you maybe 10 seconds. On the 10th month, we would have $140. So again, this one was not asking for a formula, so we maybe didn't need it. But I do like to have the index values in there just in case I can notice an explicit formula and save myself some time. Or if that doesn't work, kind of figure out what is the pattern going from one term to the next to think of it more from a recursive standpoint. What did I do to the previous term to get to the next term? And since this is only asking for the 10th, it's not the end of the world to just go to a calculator and hammer that out. All right, that's it. You guys know the drill. If you have any questions, let me know.